कामाला लागून गेली आता अजून झोपेत म्हणून काय काय कामाला लागून गेली म्हणून ते ना
Good morning. Hello, Ankita. Good morning. Good morning, Ankita. Am I audible? Not able to hear you. Hope that things are, and just waiting for the others to join, then we can start. Good morning, Tejas. Ankita, good morning.
Good morning.
तेजस, बाकी लोग आ रहे हैं? कुछ पता है?
नहीं सर, नहीं पता, मेरे पे घर पे हो अभी।
ओके, कोई अभी तक लॉग इन नहीं किया है, तो शुड वी वेट और स्टार्ट?
वेट सर, 5-10 मिनट रुकते हैं, उसके बाद देखते हैं।
So today we'll be doing multi-class classification using deep learning. And we'll be using the E. coli dataset. I think the E. coli dataset you all have, isn't it? Please confirm. Do you have the E. coli dataset? Hello, Ankita, Tejas. Okay, let's get started. Acha, confirm karo, and do you have that data set with you all, the E. coli data set? I'm not able to hear you. Hello. You can send your responses on the chat also. Hello, Ankita, Tejas. You don't have the data set. Okay. But I thought, one second, just check your data sets list of data set. I'm sure you must be having that E. coli. Wait a second, let me tell you where you did that. Look at the decision tree. In there, we did the decision tree using the E. coli data set. Use that data set. Did you get it? Okay. What about you, Ankita? Have you got do you have the data set with you? Okay, let's start. So we'll quickly go through that data set first. So this is the data set. So we can see that there are different types of E. coli, which is a bacteria. So if you scroll down, you see there is a CP type. Then IM, IMS, IMU, there are different types of bacteria, which is the prediction that we have to do based on the different features. So we have sequence name, MCG, GVH, all these things are the different features. Okay, so this is the Y variable. And then you see that sequence name is a text. So we can drop this particular column. And then MCA, GVH, if you see all these values. Okay, now one thing is everything seems to be lying between 0 and 1. So it probably looks like it is already been standardized. So just check if it is standardized or not. If it is not, then standardize it. Otherwise, you can leave it as it is. Okay, so that is one thing. Then if you remember, there was one EDA that we did. The values for LIP and CHG, they seem to be having the same numbers, 0.48 and 0.5. So we can check for singularities. Okay, so these are the two EDA that we have to do. And then, of course, we have to convert them into the one-hot encoding that is on the Y variable. Now, what is the difference between converting the data into label encoder versus one-hot encoding? So I'll just quickly explain that process and then we can start. Nikita, can you mute yourself? There's a lot of noise coming from there. Hello, Ankita. Can you mute yourself? Good morning, Yash.
Good morning, sir.
So I was just telling that we'll be starting the multi-class classification. Now, what is the difference between Ankita, can you please mute yourself? I think she's not there. Okay, anyway, so yesterday in the binary class, we did label encoding. So label encoder is going to convert the data from 0, 1, etc. based on the alphabetical order. Okay, so A will be 0 and Z will be the last number. Okay. Now what happens when we have a multi-class classification? So in a multi-class classification, the way in which we have to convert is known as the one-hot encoding. Ankita, if you are there, please mute yourself. Thank you. Okay, so what happens in a one-hot encoding? So let's say that I have my Y variable and there are 3 classes, or let's say four classes, A, B, C, and D. And the first record, so this is record, and I'll say class. So this is record ID 1, and this is B. Record ID 2, this is C. Record ID 3, this is A. And record ID 4, this is D. Okay, now I have to convert this into a number. Now I cannot use a label encoder because label encoder will do the numbers 0, 1, 2 based on the numeric sequence, based on the alphabetical order. Okay, so I cannot have a random number to my labels. Now, if I have to do a label encoder here, what will happen? A will get a value 0 and D will get a value 3. Okay, this is wrong. Everything should get the same number or same weightage. That is why we have to do one-hot encoding. Okay, so what will happen is this gets converted into a target, and the target will resemble something like this. So B will be 0, 1, 0, 0. So this represents A, B, C, and D. The second one will be 0, 0, 1, 0. The third record will have 1, 0, 0, 0. And the fourth record will be 0, 0, 0, and 1. Is this clear to everyone?
Yes, sir.
Okay, so we have to convert the y variable into a target, and this is the one hot encoding method. And once we do the prediction, okay, once we do the prediction, we have to reconvert the numbers back into the original form. So we build the model using the one hot encoding. We do the prediction. So prediction will give us numbers. Now from the numbers, we have to convert this number, convert back to original class. And then, of course, the usual confusion matrix and all that, those things will remain as it is. Okay, so that's the sequence. So let's get started. So let's go to Python.
सर
Huh?
वन हॉट कोडिंग में जो
हाँ.
पहला कॉलम होता है वो रेफरेंस वैल्यू रहते हैं ना?
नहीं, इस पे वैसा नहीं है, because this is the y variable that we are going to convert, not the features.
नॉर्मली हम वैसा करते हैं ना?
हाँ, that is only for features.
ओके,
ठीक है, ये हमारा फीचर नहीं है. This is my y variable. So this has to be treated in a different way. ठीक है, मैं जब जब रिजल्ट देखेंगे तो I'll show you. Any questions from anyone? Are the steps clear to everyone? Okay, so let's get started. So let's start with the loading of the libraries. So first is pandas. Then pre-processing. Then train test split. Then classification report. Then the DL libraries. So from Keras.model, sequential model, and then the dense layers. So you will see that there's a lot of similarity in the code of the classification that we did yesterday. Next, we will read the file. So read this from your path. So you can see here the data. Now, one thing to notice, I explained this earlier also, that the Y variable is called LSP and this is arranged in a group. Okay, so all the CPs are together, all the IMS are together. So we need to reshuffle the data set. Done? Done till here? Then drop columns which are not required. So data.drop columns equals sequence name. So now you can just verify whether the column has been dropped. So data.columns. So now you can see that sequence name has been removed. Done? Okay. Now recall that in the decision tree, I'll just open the decision tree code that we did. So we have the decision tree E. coli classification. Okay. Now if you look at this code, mentioned that you have to do the singularity check. I'll just show you that part. Okay, this one. Check for singularities for the columns CHG and LIP. So I'm just going to copy this entire thing and put it here. Okay, singularities means where the data is having the same value 85% or more in a given column. Okay, so here there are two columns. One is called CHG, one is called LIP. So I'm going to check for the value counts. So here you can see that 0.5 is more than 90%. And if you look at the value for LIP, that is also more than 90%. So that means these two columns have no significance. So I can remove this. Okay, so since the percentage of value of a single value is over 90%, the features can be removed. Is this clear to everyone? Why we are removing these two features?
Similar value in 0.45 and 5.
The same value. See, if you look at the column called GVH, sorry, not GVH, CHG. Okay, look at the CHG value. The values are 0.5 and 1. So out of 336 records, 335 values have CHG as 0.5. So it is almost 99%. So we can remove that particular feature. Okay, so now we can drop this. So data dot drop columns equals CHG LIP and then in place equals true. Okay, now check the columns. So data dot columns. And now you will see that CHG and LIP, they have removed from the data. So now we have a data which contains only 6 features. Now we will shuffle the data set. Since the data is grouped by the Y variable class. Okay, so we will shuffle the data at random. So data equals data dot sample. So I want to sample all the 100% of the records. So I will give the parameter as fraction. So frac equals 1. Okay, so now if I look at the data, you will see that all the Y variables, instead of a group, now it has some randomness to it. So it can keep doing the sampling till you feel that there is enough randomness in the data. So I'm happy with this shuffle. So we can leave it as it is. Okay, now I'm doing a data.describe just to check if the data is already in the standard form or not, because I saw that most of the values are having fractions. So here you see that all the columns, the minimum value and the maximum value, it lies between 0 and 1. Okay, look at MCG 0.89, GVH 1, AAC 0.8, ALM1 1, and ALM2 is 0.9. So it seems that the data is already standardized. So there is no need to further standardize the data. If you want, you can do it, but it is not really required. So just make a Just comment that from the data, data lies between 0 to 1. Okay, so you can just also make a note if you wish. Data can be standardized. ये वाला clear है? Is this clear to everyone?
Yes, sir.
Okay. Okay, so now convert the y variable into one hot encoding. Now to convert the y variable into one hot encoding, it has to first, we have to convert it to a label, and the label has to be converted into a one hot encoding. Okay, so the process is first convert to label encoding, or I'll say do label encode. And then convert label encode to one hot encode. So let's do the first part, that is converting the label to a one hot to a y variable into a label encoding. So LE equals preprocessing dot label encoder. So create a class. So I'm going to create a new column called data dot target. So target is the column equals LE dot fit transform. Now, what is the y variable name? What is the y variable name? It is LSP. Okay, so I'm going to convert LSP. Okay. And now if I do data.target, so here you can see the target becomes a number 0, 1, 2, 3, 4 based on the values of the LSP. So let me just print those two values. LSP target. Okay, so you can see CP is 0, IM is 1, IMS is 3, PP is 7, and IMU is 4, OML is 6. So every LSP gets a number between 0 to 7. Is this clear to everyone?
Yes, sir.
Yes, sir.
Okay. Now, if you want, this step is actually optional. To retain the mapping of LSP and target. Okay, in case if you want to retain the mapping, you want to check whether the values are mapped properly after you do the prediction. So you can have this as a reference. Okay, this is not compulsory for you to do it. So we will create one data frame to store the mapping of the LSP and the target. So you can just put here df underscore map equals yeah, you can say for analysis if required. Okay. Okay, so you can see here that I have LSP and the target. And you can also do df map dot value counts. Oh, sorry, df map dot LSP dot value counts and df map dot target dot value counts. Okay, so it will return the same number. So CP is 0, IM is 77, PP is 7. So the map has been done. So now you can have this as a reference. And now I can drop the old Y variable. So now you can write data dot drop columns equals LSP in place equals I do data dot head. So now you can see that I have the data and my target column is the number and not the string anymore. Finished till this point?
Yes, sir.
Okay. Okay, now the next step is, before we convert, we have to first split the data. Only then we have to do the conversion. So let's split the data into train and test. So train X, test X, train Y, test Y equals train test split data dot drop target comma 1 data dot target so I'll just take 0.25. So I'll do a 75-25 split since I have 300 plus records. So train X, train Y, test X. So 252 records in the training data and 84 records in the testing data. Done?
Yes, sir.
Okay. I'm just doing a small test. Okay. Now, if now in a multi-class classification problem, if there are classes 1, 2, 3, and 4. Okay. Okay. Let's take, okay, 1, 2, 3, 4. Okay. So here I have training and here I have testing. So if train contains the class 1 and test does not contain the class 1, can I do a prediction? Will it make any effect? Training contains 1, testing does not contain the class 1. So will the prediction be possible? So you have to ensure that the training classes are also present in the testing data. Okay. So training. So if you look at the training classes, So it is 0, 1, 2, 3, 4, 5, 6, 7. And if you look at the testing data, so it has 0, 1, 3, 4, 5, 6, 7. Okay. So 2 is missing. So that means the classes are all present. But it should not be the other way, where the testing has 2, but the training does not have 2. Okay. So here we are okay. Well, and we can go ahead with the classification. Now we'll do the one-hot encoding. So you can just write here, check if the classes in train Y is more than or equal to test Y. So now convert the label encoders into one-hot encoding. So first find out how many classes are there. That is the total count. So we can write data dot target dot unique. Okay. Now if I do data dot target dot unique, what I get is only these numbers. Now I have to find the length of it. So there are total 8 classes. Get the total number of classes. Okay, now I'm going to convert them into a Y variable in form of a one-hot encoding. So I'm just going to show you first what is the old value of train Y. So old value is this. Now one-hot encoded value will be train Y equals. Now there is a method in Keras which is called as to category. So under Keras you have a utility library, and under this you have a library called to underscore categorical. Okay. So this will take 2 parameters, which column to convert to one-hot encoding and how many classes are there. And first, let me show you the output of train Y. Now see the output of train Y. So here the value is 7, the old value. The new value is 0, 1, 2, 3, 4, 5, 6, 7. So this becomes the heading. And the value is 0, 0, 0, 0, 0, 0, 0, 1, which is this one. Look at the third record. The third record is, the type is 1. So this will be 0, 1, 0, 0, 0, 0, 0, 0, which is this one. Is this output clear? Hello?
So repeat again.
See, the old value of train Y had the single digit, correct? Which represents the class.
Yes, sir.
So record number 290, the class was 7. Record
7.
number 291, the class is 7. Record number 175, the class is 1. Okay. Now, when I'm doing a multi-class, I need to convert this into a one-hot encoding.
Okay.
So how many classes are there total? There
7.
are 7 classes.
Get 0 as 1.
Starting from 0. So 0, 1, 2, 3, 4, 5, 6, and 7. Now, if I look at record number 290, 290 is class number 7. So how do I represent class number 7 in a one-hot encoding form? So 7 will have 1, other will be 0.
So clear.
Okay. Okay. Similarly, do it for the test data. So test y equals keras dot utils dot 2 underscore categorical test y and classes. Now print the value of test y and you will see that test y also has a similar kind of a output. So now we can define the parameters for artificial neural networks. So first start with input node. So how many input nodes are there? That is going to be length of trainx dot columns. So there are 5. There are 5 columns. How many output node? That is going to be only 1. Correct. Now, how many nodes that you want inside the layers? So nodes, so you can take any number of nodes. So let's take 6 to start with. This you can configure. Configure as per the result. Now build the network. So again, you can either do it as a function or you can do it as a set of sequential steps, what we did yesterday. So I can call this as model 1 equals sequential. Then m1 dot add dense layer units equals nodes. That is how many nodes you want. What is the activation function that you want? So you can play around with the activation function. So you can maybe take tan hyperbolic function to begin with. And input dimension, you can give this as input node. So this is layer 1. Hidden layer 1. So let's create one more m1 dot add dense Loads. So I'm just going to try with ReLU and see if it is going to make any difference. So activation function equals ReLU. Then layer 2. And then finally the output layer. It's units equals output node. Can anyone tell me what should be the activation function here? For the output layer?
Sigmoid.
No, no.
Sir, yesterday we used that
What is it?
TANH.
No. I mentioned this in the class that activation function for binary is sigmoid, and for multi-class it is softmax. Do you recollect what is softmax function?
Yes.
Yeah, what is softmax? See, when you have, let's say, 5 classes. Okay, the classes are C1, C2, C3, C4, and C5. Okay. Now, what softmax function does? This is the list of classes. Now, this is going to predict the probability that a given record. So let us say this is the record. So what is the probability that record 1 is C1? So let's say it is 0.6. What is the probability that the record 1 is C2? So this is going to say 0.15. So what is the total? It is 0.75. Probability that it is of type 3. So let us say it is 0.1. So now what is the probability? Total probability 0.85. The probability that record 1 is of type C4, let's say it is 0.2. So now what is the value? Sorry, not 0.2, 0.12. So 0.12. So how much is this? 5 plus 2, 7, 97. And the last one is 0.03. So the sum total of the probability should add up to 1. And after it does the probability of each of these classes, now it will find out which is the maximum of all these numbers. So max of all these numbers is what? 0.6. That corresponds to C1. So record number 1 will be classified as C1. So this is what softmax function does. Is this clear to everyone?
Yes, sir.
So always, whenever you have a multi-class, the activation has to be softmax, otherwise a model is going to overfit. Next, compile the model. So M1 dot compile. The optimizer is known as the Adam optimizer. So you can use this. The loss function for a binary classification, the loss function is binary cross entropy. For a multi-class, it is called categorical cross entropy. Categorical underscore cross entropy. And the matrix is going to be accuracy. Okay, so you can also put in the definition of parameters, you can also put epochs and just start with a small number, let's say 300. So compile the model and then train the model on the train data set. So m1.fit train x, train y, epochs equals epochs and validation split equals 0.2. Okay, so don't run it now, just write the code. We'll take a break and after that we will run this and then do the prediction. So predict on test data set. Okay, so we'll take a break now and after that we will run this whole thing till the prediction. Okay, so 15 minutes, by 10:50 we will meet.
Okay, sir.
Okay, let us start.
Yes, sir.
Now we can build. So now let's compile this one by one. So start with sequential. Then add the first layer. Now add the second layer. Then add the output layer. Now compile the model. And then now fit. So here it says value error, shapes are incompatible. Okay, so we just need to figure out what is wrong here. Train X and train Y. Okay. So this is train X. So I suspect the problem could be because we have not done this the splitting. I mean, not the splitting, the scaling. So we'll just try to scale it and see. Maybe that could be an issue. Okay, so we'll just scale this data here. So data underscore std equals data.copy. So this is what my doubt was, that if you need that scaling or not. So let's do this and see. So you can use the min-max scaler to scale the data. So what we did yesterday. So you can use that same. So equals processing dot min-max scaler. So data underscore std dot malloc equals dot fit transform. Then data underscore std dot target equals data dot target. Okay, and now we can use data underscore std dot head. Now, instead of doing the data here, so I can do data underscore std. Okay, so this is already done. So now the next thing that we have to do is transform the data. Have you done till this point? Hello?
Yes, sir. Yes, sir.
Yes, sir.
Okay. Now there is a couple, the sequence has to be maintained. Okay. So I'll just remove this. So first, so here you can say standardize the data set. Okay. So first is make a copy and then the min-max scalar. Okay. And now we will do the label processing. So here I have already done the label encoding. So this label encoding has to come to the top. Okay, so this is what you have to do. Because, okay, so this is the only change you have to do. Okay, and now this is going to be data underscore std, data underscore std. So these things will remain as it is. Okay. So now things should be fine. Okay, so just that one change that we have to do, that is we have to standardize and get the data into the array format. So now input mode, output mode, nodes, epochs. Now let's try to build it and see if this is working. Are you getting the error or is it working for you?
Getting error.
One second. Let's start from the beginning. Maybe I have missed out any step. Okay, so let's start from here. Data. Then drop the unwanted columns. Then shuffle the date. Okay, let me sequence name not found in the access. Okay. Data.head. Remove the sequence name, data.columns. Okay. Okay, now I'm going to remove these two columns as well. Then data.columns. This is fine. And then shuffle. Okay, now after shuffling, I'm going to do the pre-processing. So label encoder. Okay. So target. Okay, so now I'm getting the target. Okay, so far so good. Next, I'll create the mapping table. So I'll just move this here. And check whether the mapping is fine. So this is fine. Okay, and now I will drop the old variable name. Okay. Now let me check the data again. So data dot head. Okay, now this is fine. Okay, now standardize the data. Min max scalar. Okay, this is fine. Okay, so I just run the whole thing again. Then convert to one hot encoding. So I can see here there are 8 classes. Okay, so input node equals train x dot columns. Output node is 1. Okay, maybe I can change the number of nodes. I'll just make it 3 and see if that is the problem. Epochs, I'll retain at 300. So units equals nodes, activation is tan h. This is fine. Input dimension equals input node. Were you able to run this now?
Site is not maintained.
Sorry?
The train test model on the data set, the fit करता है ना हम, उधर बैच साइड मेंटेन नहीं किया है.
क्या मेंटेन नहीं किया?
बैच साइज है ना, वहां पे मेंशन नहीं किया है आपने.
एक मिनट. There is nothing. Classifier, sorry, classifier is my M1. So train X, train Y.
Yes,
is so much. Sequential. Classifier is my add. Contents units equals nodes. Activation is input tem is input node. Then M1 dot add dense units equals nodes. Activation is ReLU. Okay, output layer. Okay. Output layer. This is the problem. Output में कितने values आने चाहिए?
3, 7, 8.
Output is, we have 8 classes, isn't it?
Yes, sir. Yes.
So not 1. Okay, that is a problem. So output should not be 1, it should be 8. That is the problem. Okay. So just make a note here. So output node should be number of classes. Now it should be fine. ठीक है, ये change कर लो and then build this network again. There you go. So it has nothing to do with the standardization part. It was the mistake on the number of classes defined. Okay. हो गया ये वाला? Is it working now for you?
Yes, sir.
Okay. So predict on the test data. So we'll call this as prediction y equals m1 dot predict test x. Now let us see what is the pred y, what is the return value. Okay, this is going to be interesting. Now, if I do the pred y, I'm just taking the first 3 records. Now look at the output of the predictions. Now see how many values are getting predicted. 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's take only one record. Okay, so this is the prediction for the first record, and see how many predictions are there. There are 8 predictions. This is class 0. This is class 1. This is class 2, class 3, class 4, class 5, class 6, class 7. So total there are 8 classes. Now record number 1, the probability that it belongs to class 0 is how much? 0.005. It belongs to class 1, 0.46, 0.01 for 2, 0.004 for this. Okay, now if you add up all these numbers, you will get the value as 1. Now, can you tell me for which class does the record number 1 belong to? It is going to belong to the maximum of the probabilities. So which one? 0.46. So that means the prediction for this record is class 1. Is this clear? Yes, no?
Yes, sir.
Okay. Now what we have to do is to identify the class. Now what we have as the prediction is the number. Okay, so this is 0, this is 1, this is 2. Now we have to find out what is the value corresponding to 0. So 0 is what class? It is IM, I think, or whatever may be the value. 1 is probably CP, 2 is something else, IML. So we have to do the reverse transformation. That is, from 1, I have to go to ML. From 2, I have to go to IML, or whatever may be the translation done. So this is called reverse transformation. So let us see how to do the reverse transformation. So that is why I asked you, you create a mapping data frame so that you know which value gets what. So predict on the test data set. So this will have for each class, there is a probability. Select the max probability to determine the prediction. Select the maximum probability to determine the predicted class. Okay. So now let us see how to do the reverse transformation. So get the actual class and predicted class. Okay, now how do I get the actual class and predicted class? So let me show you the technique to do that. So first I'm going to convert the pred y into a data frame. So convert the predictions into a data frame. So pred y equals pd dot data frame pred y. Okay. Is this clear? Now, what are the actual classes? Now, if you look at the actual classes, it is coming from test y. Okay, this is test y. Okay, so let us assume that this is the test-wide classes. So I'll just convert this into a data frame so that you can see how it looks like. Okay, there you go. Now, this is the first record that I have. This is the first record. This is class 0, class 1, class 2, class 3 till class 7. That is, there are 8 classes in all. What is the class of the first record? Can you see and tell me what is the class of the first record? Hello.
One.
Sorry? What is the class of the first record? The class of the first record is 1. The class of the second record is also 1. The class of the third record is 0. Okay, now how do I get the value 1, 0, 4, whatever may be the case? So how do I get this? So there is a function called ID max. So what this function will do for each of the rows, it is going to find the maximum value. And for that maximum value, fetch the column name. So here, what is the maximum value for the first row? The value is 1. What is the corresponding column name? It is 1. So we are going to use this function called ID max to find out what is the actual class and what is the predicted class. Clear?
Yes, sir.
Okay. So actual classes. So from the data frame, ID max, and for which axis I want. So I want it for the columns. So I'll give axis equals 1. Okay, now if I do actual classes, so now you can see that for the first record, now you can do the mapping. So for the first record, it is 1. For the second record, it is 1. For the third record, it is 0. For the fifth record, which this one, it is the last one. So I'm getting 7. Okay, understood? Now, if this is my actual classes, what is the translation of this? One is what? So this is where I have to use a very useful function called as inverse transform. That is, I have to convert now one into the actual class. So I'll call inverse transform. Actual classes. And now see. So 1 is IM, 0 is CP, and all the corresponding mapping for each of these numbers. Is this clear to everyone?
Yes, sir.
Okay. In fact, I can do the same thing for the predicted class also. So pred underscore classes equals pd dot data frame pred y dot id max axis equals 1. And now store the actual and predicted values in data frame. So I can call data frame 1 equals pd dot data frame actual class is actual classes actual label. So I'm going to use the inverse transformation, which is this. Then predicted class is going to be pred underscore classes. And then predicted label is going to be pred underscore classes. Okay, now print df1. Now you can see actual class is 1, actual label is IM, predicted class is 1, predicted label is IM. Actual class is 0. So 7 for the last fourth record, actual class is 7, predicted class is 0. So this is how you convert multi-classification into one-hot encoding and reconvert it back into its original class. Is this clear to everyone? Now print the actual and the predicted labels. You can use the cross tab for the confusion matrix. Okay, now this is the confusion matrix. So how many CPs are there? 34. How many CPs correctly predicted as CP? 34. And finally, the classification report.
सर मेरे सिस्टम भी एरर है
क्या हुआ?
एरर आ गया है जो आपने प्रेड क्लास किया ना
हाँ
आ रहा है जो ऑब्जेक्ट गेट एट्रीब्यूट सेल्फ नेम ऐसा आ रहा है
स्क्रीन शेयर करो.
तो कैसे तो विजिबल हो रही है क्या
नाही दिसत. स्क्रीन शेअर कर, ऍप शेअर नको करू.
स्क्रीन शेयर के लिए
हाँ यश क्या एरर है?
तेजस तेजस
तर तेजस कॅमेरा
INT नहीं IDX max.
ओके
Spelling mistake. IDX MAX.
ओके सर ओके
Okay, so उसके बाद confusion matrix will give you the confusion matrix on the right hand side. Actual classes versus predicted classes. So CP as CP, how much? How many CPs are there? 34. How many predicted CPs? 34. So which is 100%. And then this is the classification report. Recall देखो, IMS is 0, IMU is 0, and OM is 0. So that means my model has not done a good prediction. Now I have to think of ways how we can make this model better. Clear है ये?
यस.
यस सर
So here I'm just writing a comment since there are 3 classes which weren't getting predicted. Model needs improvement. Okay, so now you can think of other parameters. That is how we can include the layers if you want, change the activation function, the number of epochs, all these things, and then see if we can get a better model. So use hyperparameter tuning to optimize. Okay, so that completes the multi-class classification using deep learning. So are the steps clear to everyone? Ankita, Tejas, Yash.
सर हमने इन्वर्स क्यों किया है इसमें, एक डाउट है. इन्वर्स क्यों किया है?
इन्वर्स किया है क्योंकि हमारे पास जो क्लासेस है वो नंबर है ना.
Okay.
And what is my original class? जब हमने डेटा रीड किया था,
07.
what is my original data? यहाँ पे देखो, this is my original data. ठीक है, यहाँ पे टारगेट 3-4 हमने किया था, बट ओरिजिनल डेटा क्या था? LSP था ना.
LSP था.
ओके, तो यहाँ पे देखो हमने वो मैप कहाँ पे किया है, यहाँ पे DF मैप. Okay, so what was my original data? LSP, IMS, IMU, PP. So I have to get all the numbers to its original form, which is LSP.
Oh,
So वो inverse transform से
got
वो.
it.
So you can, before you leave, you can just build one more model, optimize, and then tell me if it is giving a better result. Okay, so do this exercise now.
Sir, only change the features and epoch value, na?
So the things that you will change. Number one is you will be changing the number of epochs. Second one is you will be changing the activation function, the number of layers, the number of nodes.
Okay, sir.
So build just one model and check the difference and show me. Okay, finished. So next week, we are going to start with the text analytics. So I'll tell you the installation steps next week, that is using NLTK. So first we'll start with regular expressions, how to handle basic text processing and how to find patterns. And then we'll do the text classification using NLTK. And also try to finish all your exercises, other things on LMS.
Sir, still don't have the access to LMS.
Achha.
Yesterday talk with Utkarsha, they told the technical team is not available in today and tomorrow. They can be provided the LMS access at Monday.
Achha, okay, fine. Okay, okay. So do you want to go offline and do the assignment?
Yes, sir.
There's nothing new. We have finished with the deep learning using for classification and regression.
Okay.
Okay, so we will stop here and we'll meet next week. Okay. Okay, thank you, everyone.
Okay, sir. Bye.